Hi everyone, today we are going to learn how to perform a sensitivity analysis in MSC Nastran. By the end of the video, hopefully you will understand what is the significance of obtaining sensitivities. You'll understand 3 different methods of prompting MSC Nastran to write out your sensitivities. And then once it's written out, I'm going to explain how to interpret the sensitivities, and then towards the end I'll explain or go over some final thoughts. My email address is here in the bottom right hand corner. I'd be more than glad to go through more training with you to support you on one of your projects. Definitely reach out to me, send me an email, and we can schedule some time to talk. So now, starting with number 1, what is sensitivity analysis? This is nothing more than just computing the partial derivatives of your objective function and your constraint functions. Throughout this video, I'm going to use these functions as an example. My first function, f, is my objective function. This is x1 squared plus x2 squared. This is the surface plot that you see here on the right. I also have 2 constraint functions. G1 is equal to this, G2 is equal to that. And we're going to calculate our sensitivities or partial derivatives at this point 3, 4. I've already gone ahead and taken time to set up this problem in Solution 200. There's a video called Best Compromise and Feasible Design, or I'll walk you through the process of defining your entire Solution 200 model for this example. So feel free to look there to look at what the setup process is. In this video, I'm going to tell you the one-line statements that will prompt MSC Nastran to create your sensitivity values. On the next slide, I've taken time to calculate the exact derivatives. So the partial of f with respect to x1 is at this point 3, 4 is 6. And here the same for f with respect to x2 at 3, 4, which is 8. I've done this for g1 and g2, and the values are here that you see. We'll use these values to confirm the sensitivities calculated by MSC Nastran. Now let's go ahead and exit my PowerPoint. In the video description below, there's a zip file. Feel free to go ahead and download that so you can follow along. On my desktop, I'm going to create 2 or 3 folders, one called method 1, the other one called method 2, and the other one called method 3. And then in each directory, I'm going to go ahead and take the PDF file and put a copy there just to show you the 3 methods. So let's go ahead and take the zip file. We'll take a PDF copy and put it in method 1. We'll do the same for method 2 and method 3. We'll go ahead and open method 1 and open the respective PDF file. And here, this model is already set up to perform this optimization example. So that's the one described here in the graph in this problem statement. And it's the same one discussed in this YouTube video. Now, to prompt MSC Nastran to write out your sensitivities, you have to do nothing more than just type in one statement. So here in variation 1 or method 1, there is a case control command called dsaprt. Copy that into your case control section. So here on the left hand side, I'm just giving myself space in the case control section. Paste that line there, and then save the file and run this PDF file in Nastran. MSC Nastran will then go ahead and calculate the sensitivities. And keep in mind, during a normal optimization process, the sensitivities are calculated at each design cycle. Here, the line is set up in a way where it says, perform the sensitivity calculation only for the initial design. If you were to change some of these settings here, it will then print out the sensitivities for each design cycle of your optimization. But again, we have just computed the sensitivities for the initial design, so 3, 4. In the F06 file, this is where you will find your design sensitivity coefficients. So here, if you scroll down after the summary of the initial analysis, you'll find a section called Design Sensitivity Matrix Output, Response Sensitivity Coefficients. At first glance, the table is sort of hard to read, and this is where I have a slide describing how to read this table. Imagine that this is column 1, this is column 1, this is column 2, this is column 3, and then this is column 4. In this first column, we have a value of the objective function at 3, 4. So this is the value of the objective function at the initial design. If you plug in 3 and 4 into the objective, you should get a value of 25. This is the value recorded by the F06 file. Here in the second row, this is the value of G1 at 3, 4, so it's 13. Here's the 13 here. And the same for G2, 1.8125 and 1.8125 here too. After the second, we have the third column. The third column is indicated by these design variable coefficient lines. So here, design variable coefficient, design variable coefficient, and design variable coefficient. Under the second set of design variable coefficient, this is where we have the partial derivative of f with respect to x1 evaluated at 3, 4. Here the value is 6 from MSC Nastran, and here's the actual value, 6. So we're on par with our results. In the next row, this is where you find the partial of G1 with respect to x1 at 3, 4. You should get a value of 6, and this is what MSC Nastran reports. And then the same thing for the next row, partial of G2 with respect to x1 gives you 1, and this is what MSC Nastran reports. Same thing is true for the next column, partial of f with respect to x2, 8, 8. Here, partial of G1, x2, 2, 2, and so on and so on. So that's how you read the table or the output. At first glance, it's kind of difficult to read, but hopefully this diagram I just showed you makes it a little simpler. Let's go ahead and move on to the second method. This method 1 is the formatted sensitivities method. The next method is going to print out your sensitivities in an unformatted fashion. So let's go ahead and copy the one-line statement we need. And we'll go ahead and copy that here. Again, I'm just using the spacing to really show you where the line goes. And then once you make the edit and you save, let's go ahead and perform the design sensitivity calculation with MSC Nastran. So we'll go ahead and use MSC Nastran to pick that new BDF file, and we'll run it. I'll create a new F06 file, which includes these new unformatted sensitivities. So scroll down after the summary of initial analysis. Now, your sensitivities are written out a little differently. Here it's very different from the formatted method, and now I'll take time to describe how to interpret these new sensitivities. So with method 2, you have them sort of displayed in almost a matrix fashion. So here in red, I've boxed which sensitivity coefficient it corresponds to in your sensitivity matrix. So here, if we look at the output, this is column 1 and this is column 2. Column 2, row 1 corresponds to the partial of f with respect to x2. Hence, we get a value of 8 here and the 8 here. If we look at column 1, row 3, we have this 1, which corresponds to the partial of G2 with respect to x1. And you'll notice that the printout from the F06 file is the sensitivity matrix transposed. So here at the 5.99, this is row 1, column 1 of the sensitivity matrix. And this bottom right hand corner is row 2, comma 3 of the sensitivity matrix. So here, let me use a laser pointer for the last one. So this 1.25 is row 2, column 3 of the sensitivity matrix. And here, feel free to pause the video and carefully look at how this box corresponds to this box to really understand how to interpret the unformatted sensitivities. Now, let's go ahead and close that. And now there's an alternative method of printing out these results, and I'll take time to describe method 3. Now, method 3, let's go ahead and take a look at that. Go ahead and close all my notepad files, and then in method 3, open the BDF file, and then we'll move this to the left. And then we're going to expand on the last statement. We're going to paste the same DSAPRT method, but note that it now says export. So let's go ahead and just copy these 3 statements. So these 2 statements should go in the case control section, and then this top statement should go in the first line of your BDF file. And then we'll go ahead and run this new BDF file. What this does, it prompts MSC Nastran to produce unformatted sensitivities, and it should write out those unformatted sensitivities to a separate OP4 text file, or a file you can open in Notepad. So here, let's go ahead and take a look at the F06 file here on the left, and let's go ahead and open the OP4 file, and then we'll move the file to the right. Now, if you scroll down in the F06 file, there's one piece of information we need. There's a section called Identification of Columns in the Design Sensitivity. This are the columns for your sensitivity matrix, and here on the right is the sensitivity matrix transposed. So here, let's go ahead and take a look at my PowerPoint slide, or I'll have to use these side by side actually. Let me zoom in on one of these. So again, this matrix that you see on the right is your sensitivity matrix transposed as I described in the previous method too. What you would then need to do is refer back to the F06 file so you know what the column headings are. So here, let's go ahead and just go through a quick example. So I'm going to construct our sensitivity matrix here. So the first row, column 1, would be 6. The next column would be 6, and then the next one would be 1. Here would be 8. You would have 2, and then you would have 1.25. So this first column of your sensitivity matrix corresponds to column 1 here, your DRES2 entry ID. This is your function F. And then here you see the respective entry ID. This is your G2, or G1, sorry. And your next column would be G2. And then so 6 would be the partial derivative of F with respect to x1 at 3, 4. This would be the partial derivative of F with respect to x2 at 3, 4. And you would do that for column 2 and column 3. And so that's how you read the sensitivities in your OP4 file. Let me go ahead and switch back to my PowerPoint. And let me see if I have any more comments here. Nope, I think that is it for method 3. And now I believe I have a few last comments to make. Perfect. So that was a quick glance of how to prompt MSC Nastran to output your sensitivities in your F06 file or your OP4 file. Also, I do provide more advanced training for optimization, or specifically size optimization. In that more advanced training, I'll walk you through how to output the sensitivities for actual structural example. This video used a very simple algebraic example that you'll find in any college course. But then in the more advanced training, I upgrade to actual structure, how to do the same procedure for that. I also detailed different methods of outputting your sensitivities. There are steps to normalize your sensitivities so you can then perform your comparisons. I detailed that in my more advanced training here. The goal of the video was just to give you an introduction. If you have any comments, questions, feel free to reach out to me here at the email at the bottom right hand corner. And as always, you can also leave a video comment in the description below. Thank you for watching, and I look forward to having you watch my future videos.